In this example, we want to determine which of the following systems would be the best to choose if I wanted to make a buffer with a pH of 3.4. And then the second part, I want to know what is the ratio of the concentration of the buffer components required to get the pH to exactly 3.4. So let's answer the first part first, right? So which one of these would I choose if I'm looking for a buffer with that pH? So we know that buffers work best when the pH is equal to the pKa of the acid plus or minus 1. So we want to find which one of these systems has the pK of the acid closest to 3.4. So to find the pKa, all I need to do is take the negative log of the Ka. So the first one, if I do the negative log of 1.1 times 10 to the minus 2, I get 1.95. So that is not within 1 of 3.4, so that one's probably not any good. Now for this next one, I have to be careful, right? So the first one, I had a weak acid and its conjugate base. Now they gave me a weak base and its conjugate acid. But whenever I'm working with buffers, if we're going to use the Henderson-Hasselbalch equation, we want the Kas. And so they gave me the Kb of methylamine. What I need is to find the Ka of its conjugate acid. And so the pKb is going to be the negative log of 4.4 times 10 to the minus 4. And that's going to give me 3.36. And at first blush, that looks pretty good. But again, this is the Kb. I need the Ka of this guy. And so the pKa is going to be 14 minus 3.36. And so that's going to be 10.64. So that's no good, right? Again, I need the pKa of the conjugate acid in the buffer, not the pKb. All right, for this last one, again, I've got a Ka, so I don't have to worry about that. So I'll do the negative log of 1.8 times 10 to the minus 4. That gets me 3.74. So this is going to be the system I would choose if I want my pH to be 3.4. All right, now we're going to answer the second part. So we can adjust the pH of a buffer by changing the relative concentrations of the weak acid or the weak base. And so I know that pH is equal to pKa plus the log of the concentration of the base over the concentration of the acid. And so when they ask for the ratio of the concentrations of the buffer components, they're asking for me to solve for that, right? That is the ratio of the concentration of base to the concentration of the acid, right? So essentially I'm going to make that my X, right? And I can plug in the pH that I actually want. I know the pKa from the last slide. All right, so if I'm solving for X, I'll subtract 3.74 from both sides. So I get negative 0.34. To get rid of the log, I'll do 10 to the minus 0.34 is equal to 10 to the log of X. So those guys cancel. When I do 10 to the negative 0.34, I get 0.46. And so I want the concentration of my base to be roughly half the concentration of my acid, or 0.46, in order to get exactly that pH.